Hello, Math 2. This video is our first lesson of Unit 1. So Unit 1 is all about reviewing function notation and working with some polynomial expressions and equations. And so this lesson is about function notation. So a quick review of function notation. You should have learned a little bit about function notation last year. So functions are mathematical relationships where each input has exactly one output. One common way to represent a function is symbolically with an equation. So functions usually have names. So the name of this function is function f. After the name of the function, you usually see a little parenthesis set right here, and that variable inside of the parentheses is telling you what your input for the function is. So f of x is usually the name of our functions. We'll have other function names as well, like g of x, h of x, v of x. That first letter though just names the function. And then it'll be equal to some expression that involves the input. And that expression gives you a rule for calculating the function's output value. So for example, if I have the function f of x equals 2x minus 5, that tells me that for each input, I double it, so 2 times x, and then I subtract 5. And that will allow me to calculate the output. So for example, if I subbed in the number 8 as my input, then the output would be 2 times 8 minus 5. Well, that's 16 minus 5, and so that output would be 11. And so we know that f of 8 is equal to 11, and we could calculate other values of the function as well. For example, if the input is 1, then f of 1 means that I need to double the number 1 and subtract 5. So in that case, I get -3 as my answer. And we could do that for any input value that we want. So here's a new function. This function's name is g, so function g of x. The rule for calculating the output value for g of x is that we square the input and then we add the input to that. So for g of 5, our input is 5. We're going to calculate 5 squared and then we're going to add 5. Well, 5 squared is 25, and so if we add 5 to that, we find that g of 5 is equal to 30. One of the purposes of function notation is just to help us when we're working with multiple equations. So if I know that g of 5 is 30, that tells me that I used this equation. It tells me that the input value is 5 and that the output value is 30. So it gives us a lot more information than just saying y is equal to 30. So now I have three functions here, f that we saw on a couple slides ago. We have function g that we just used, and I have a third function, function h, that is 3 times x. So we're going to find some outputs. So our first problem is h of -4. So we need to use function h. We know that that's the equation we're using. And function h is 3 times the input. So this will be 3 times -4. So h of -4 is -12. Our next problem here is using function g. So we're going to use that middle function. For function g, it's the input squared plus the input. So 1 squared plus 1, that is 2. And then f of n. So this is a variable here that we're inputting instead of a number, but we can absolutely do that. Remember that we just do what the function tells us to do. It's 2 times the input minus 5. So 2 times the input minus 5. Our input is n. You could write it with parentheses if it feels better for you, like a substitution of n. But if we have 2 times n, we can just write it as 2n. So even though we are inputting a variable, we can do that as well. And obviously, in this case, we don't have a number for our answer. We just have this expression as our answer. It's also possible that we might want to know which input would lead to a particular output. So for example, for h of x is equal to 3x, uh, can you think of an input that would give you the output of 15? Probably you are thinking to yourself, well, yeah, I can, because I know that 3 times 5 is 15. So that means we need the input value of 5. So then h of 5 is 3 times 5, which is 15. So the input that gives us an output of 15 is 5. This one, we kind of could just mentally think about the answer. But for some of our functions, especially more complicated functions, it's not possible to just mentally think of the answer. So I'm going to show you a procedure for finding the input value. So we're going to use our function f for this. So function f is 2 times the input minus 5. So we want to find the input or find x if we know that f of x is equal to 7. So right here, the thing that is equal to 7 is f of x. So we're going to replace the f of x with the 7. 7 is not the input. 7 does not go in for x. 7 is the value of f of x. So we put our 7 is equal to 2x minus 5. And we solve for x. Using the same solving equation skills that you've been using for a couple of years now in math. So in this case, we would add 5 to both sides of our equation. Whoa, that's not adding 5. So 12 is equal to 2x, and then we would divide both sides of our equation by 2. And when we divide by 2, we end up with x is equal to 6. Sometimes people prefer to have the variable on the left side of the equation, so I'll show you that if for this next equation if you like. So we can think about subbing in the equation right here for the f of x if you prefer to think about it that way. So that would be 2x minus 5 is equal to negative 11. And again, we'll just go through our steps for isolating the variable. So we're going to add 5 to both sides. We get 2x is equal to negative 6. And then when we divide by 2, we get that x is equal to negative 3. So these two problems were different from the problems we did prior because in this case, we were given the output and we were trying to calculate the input or figure out which input results in that output. Okay, so for this example, we have a more complicated function, but we're going to kind of just try to guess and check to find the answer. Later in the year, we'll learn how to solve this type of problem algebraically, but for now, we're just going to kind of guess and check. So we want to, for function g, we want to find the input that results in an output of 42. So we want to figure out what number, if we square it and add itself again, which number would give us an answer of 42. So a minute ago, we figured out that 5 squared plus 5 is equal to 30 because we calculated g of 5 a minute ago. So let's try another number. Let's try 6. We know it's bigger than 30, so let's try g of 6. G of 6 would be 6 squared plus 6, and that is actually 42. So we were able to figure it out kind of just by trying out a couple of numbers. There's another answer to this equation. And so if you like to think about things and figure things out, you could try to pause and figure it out. It's a negative number. And it happens to be, so pause if you want to figure it out on your own, it's a negative 7. So negative 7 squared plus negative 7, well, a negative 7 squared gives you 49, and we're subtracting 7, so we also get 42. And like I said, later in the school year, we'll learn how to find those two answers using an algebraic process. All right, so all of the functions that we have worked with today in this lesson have been polynomial functions. Polynomials are expressions that can be written as the sum or difference of one or more terms, with each term being a product of numbers and or variables. So these three expressions right here are all polynomial expressions. So you can see that they have a sum of terms. So we've got 3 terms here. When we say sum, we can also include some subtraction there. And each term is just a little product, 3 times x times x, 2 times x, 2/5 times y to the third. If a polynomial has exponents, they must be positive whole numbers. So you can see we have a couple of exponents here, and they are positive whole numbers. And fraction or decimal coefficients are allowed. So we are allowed to have the 2/5 as a coefficient, or we could have a decimal coefficient as well. Like, for example, 2/5 is the same as 0.4. So this would be the same as 0.4 y to the third. So here are some expressions that are not polynomials. Sometimes the easiest way to understand what something is to understand what it is not. So each of these has a part of them that make it not a polynomial. And in class, I had the students go through and highlight these and think about them ahead, but for the purpose of the video, I'm just going to buzz through it. Right there, I said a minute ago, we have to have positive whole number exponents. So we can't have that -2 power. We aren't allowed to have division with a variable. So we can't divide by x or divide by t in a polynomial. We are not allowed to have other operations. We're not allowed to have absolute value, and we're not allowed to have a square root of a variable. And then finally, over here, we're not allowed to have a fraction exponent. It is okay to have a fraction coefficient, but just not a fraction exponent. So no division by variables, no negative or fractional exponents, and we're not allowed to have roots or operators other than adding, subtracting, and multiplying. So these things are not polynomials. If you see these things, you know that you're not dealing with a polynomial. Again, polynomials, we're looking for positive whole number exponents, and we're looking for just multiplication and addition and subtraction happening. I would like to point out that this one over on the side, this t divided by 2, I can have something like that. I'm not dividing by a variable here. I'm dividing by the number 2. This is the same as having 1/2 t. So that one is okay and is a polynomial. Okay, so your teacher probably has an assignment for you, so make sure you know what that assignment is, and that is it for lesson 1. Thank you.